Hello everyone. In this video, we are going to discuss about linear search in data structures. This is the basic outline of this video. This video consists of introduction about linear search, C program for linear search, its time complexity and applications of linear search. Before we dive into this video, please hit the like button. It will motivate me to do much more useful content. So now let's get started. Let us consider an array of n integers and an integer element x. We have to find whether that element x is present in the array or not. If it is present, we will return the index of the element. If it is not present, we will return -1 or element not found as the output. So let us understand with the examples. In the first example, let us consider an array of 4 integers 1, 2, 3 and 4, and the target element is 3. Now we have to find whether the element is 3 present in the array or not. The target element is compared to the now first element of the array. Here 1 is compared with 3. It is not equal. So now the target element is compared with the second element of the array. 2 is not equal to 3. So now the target element is compared with the third element of the array. Here 3 equals to 3. So the index of the equal value is returned as the output, which is 2. Similarly, let us observe another example. Here let us consider an array of 5 values. Those are 10, 8, 30, 4 and 5. Here the target element is 5. Now the target element 5 is compared with the first element of the array, 10 not equals to 5. So now the target element is compared with the second element of the array, which is 8 not equals to 5. And so on, we'll compare with third element, fourth element. Now at last we will compare fifth element with the target element. They are equal, so the index of the last element is returned as the output. Similarly, let us observe another example. Here let us consider an array of 3 elements and the target element is 6. So now 6 is compared with the first element, similarly second element and third element. Here we can observe that the value 6 is not present in the array. So we will return output as -1. So this is the basic approach of linear search. Now let us execute a simple C program in C compiler. So this is the C program for the linear search approach. Let us execute once. Enter the total number of elements in the array. Let us consider 5 elements. Enter the elements of the array. Let us think 1, 2, 3, 4, and 5. Enter the key element to search. Let us search 3. So 3 is found at element 3, index 3. Now let us give a target element which is not present in the array. Enter the elements of the array 10, 20, 30. Enter the key element, let us search 50. 50 not found. So this is the C program for the linear search. We are initializing the count value to -1. So we are running the loop for n number of times, where n stands for the size of the array. Every time we enter the loop, we increment the count value. For the first time, count value is 0. Second time, count value is 1. And similarly up to n times. Every time we are comparing the current array value with the key element. If it is found, we will print that it is found and set the flag value of is false and break out of the loop. If it is not found, it will not come into this if statement, if condition statement. So if the element is not found, the default flag value is true, and it will execute as a printf %d not found. So this is the C program for the linear search. So let us see the time complexity. There are total 3 types of time complexities: best case, worst case, and average case time complexity. The best case is if the element is found at the first position of the array, then we call it as best case time complexity. In that case, we have the time complexity as omega of 1. Similarly, in the worst case, if the element is found at the last element of the array, then we call it as worst case time complexity. In that case, the time complexity will be big O of n, where n stands for size of the list. Similarly, average case is theta of n, where n is the size of the array. So this is about time complexity. Now let us see the applications of the linear search. We use this linear search in unsorted list. So when we have unsorted array or list, linear search is most commonly used to find any element in the collection. We use it for small data sets. In small data sets, we can search linearly whether the element is found or not. If we have large data sets, the time complexity increases. So searching linked list. In linked list approach, we search linearly to find whether the element is present or not. And simple implementation. Linear search is much easier to understand and implement as compared to binary search or ternary search. So these are the applications of a linear search. This is all for today. Thank you for watching this video. Kindly hit the like button, share and subscribe. If you have any doubts, please comment. Or if you want to provide a feedback, please comment. Thank you.